Alright, welcome to your video lesson for Unit 1.4, Literal Equations. So let's first start off talking about what actually is a literal equation. So something like a formula or an equation that involves several variables. So we're not just talking about there's x on both sides of the equation. We're now talking about multiple different variables. Okay, we're still going to use our skills for solving, which is SADMAP. Okay, but what's going to happen is instead of really solving, because solving kind of alludes to evaluating, which means getting an answer, we're just going to be isolating the desired variable. So just getting it by itself. Okay. So this would be an example of a literal equation, okay, because I have two different variables, an x and a y. So how is my answer for this going to be different than equations that we were solving in 1.1 or even 1.2, where we were just dealing with x's all the time? Okay, so now since you have more than one variable, your answer is going to have a variable in it. We're not actually going to be evaluating to get a final answer. It's going to be more of an expression that is our final answer. Okay, so let's take a look. So here's a literal equation because it has an x and a y, and the directions are telling me to solve for x. So what I want you to do in these types of problems is circle the variable you're solving for, okay, so that you don't lose track and get lost. Okay, so now if we're trying to isolate the x, that means we want to move everything else to the right side of the equation. What would be our first step using SADMAP? Okay, we're going to add the 12. Subtraction and addition come first. Now when I get to the right side of the equation, I can't actually add 8y and 12 because they are not like terms. So I keep them as two separate terms. Okay, so this is what we're talking about, getting an expression as your final answer since we can't evaluate. Okay, the x isn't by itself yet. We're going to have to divide. Now we want to make sure that we are simplifying our final answer. So when we divide, we want to make sure that we divide both of those values in the numerator. So you see it kind of makes a heart. Okay, so you want to make sure that you don't break the heart. So 8y divided by 4 is 2y, and 12 divided by 4 is 3. Okay, so this would be my final answer, solving for x equals 2y plus 3. Okay, so now dealing with the same equation, now we want to solve for the y instead. Well, since there's only an 8 on that side of the equation, this is definitely going to make for an easier problem. Okay, it's only one step that I need to isolate is divide by 8. And now I want to remember to reduce. Okay, so while this one may not necessarily divide evenly, you can certainly reduce. Okay, so 4 over 8 would reduce to 1/2. So this would be 1/2 x. And 12 over 8, if we reduce them both by 4, would be 3 over 2. Okay, and we do want to get in the habit of writing it in this way and not leaving it as one big fraction. Okay, this is going to help us in the future. Okay, so seems pretty simple. Let's look at some some different setups of equations here. Okay, so now for example number 2, we're solving for x, which is inside the parentheses. So there's actually 2 different ways that we could do this problem. All right, and I'll show you both ways. So the first, we could distribute. All right, that would be method number 1. So we would get 4x plus 12 equals 12y. All right, and then isolating the x, so we could circle that, we would subtract 12 and divide by 4. Okay, remembering to reduce, you do your little heart. 12y divided by 4 is 3y, and 12 divided by, or negative 12 would be minus 3. Okay, so that's option number 1. You could distribute. That's probably the first thing that you think to do when you see those parentheses. Okay, your second option could be to just divide. Okay, because the 4 is on the outside of the parenthesis, we don't have to follow SADMAP just yet. Okay, because there really are no other operations outside the parenthesis. So I could divide out that 4 as my first step, and then isolate the x by subtracting 3. And we come out to get the same final answer in both situations. So what method you choose in this example is totally up to you, and either one would be accepted. Okay, but you see you have a distribute option on the left, and then you have a little bit quicker divide option on the right, but you really kind of have to be creative and see that that's what's happening in that option. Okay, so now getting a little bit more complicated here. You have 4 different variables. Okay, we are solving for x. Now, yes, we have to follow SADMAP. However, the b is holding me back from getting to everything that's in the numerator of that problem. So because I cannot get to any other operations, since they are in the fraction, kind of have to go a little out of order. So this is kind of a special case for SADMAP, okay? But I am going to get rid of the b as my first step, and I'm going to multiply it to both sides. I'm going to put b times y. I like alphabetical order. All right, and now to isolate the x, we're going to add a. And divide by 3. Okay, so there's not really simplifying to be done over here, but we can think of each of those variables as having a coefficient of 1. Okay, and remember we like to use the heart, and we do like to separate that and split it up. So I'm going to say it's a 1/3 by and a 1/3 a instead. Okay, and again, that just little simplifying is going to help us down the line, okay, in future chapters. All right, why don't you pause your video at this point and see if you can isolate this example on your own. Okay, once you have an answer, come back to your video and let's check your answer. Okay, so solving for x, I'm going to subtract 2y. And divide by 4. and using the heart to simplify, reduce. Okay, I get negative 1/2 y minus 3/4. Were you able to arrive at that same final answer? Okay, if not, go back through and compare your steps to mine here. Okay, so a little bit different situation. What if I only have variables? What if there are no numbers and there seems to only be one operation? See, this expression over here is just kind of one big chunk. It's all put together. I don't have separate operations. So how would I isolate for the x? I would have to divide by y and then divide by z. Well, that's not going to work, okay, because we can only divide once in a problem. So instead, you can actually take two variables at a time because they're all doing the same operation. So the y and the z are what I have to move, and they're both being multiplied, which means I can divide them out at the same time. So they cancel, leaving me with just the x, and now I have a divided by yz. Okay, and a division like this, you can leave. Okay, there's really no way to make that answer look any better. There's no way to simplify or reduce that expression. Okay, so you can just leave it as a over yz. Okay, the last thing that we want to look for here is solving for y. So it's the same type of equations, same idea that we've been doing. Really the main point of this lesson is for the future, okay, to get us solving equations for y. It's really going to help us with graphing and slope-intercept form. Okay, now that's a long ways away, but it's nice to know the reason that we're doing things now and what is coming in the future. Okay, so solving for y. You're going to hear that a lot. I'm going to say solve for y, solve for y. You want to know what that means and you want to be really good at it. So in order to solve this equation for y, first thing you're going to do is move x. So in order to move this x, we're going to use subtraction. Okay, move x and then divide. I'm going to divide by -3. Okay, and this solve for y type of scenario is the reason that we have been simplifying and reducing our problems the way we have. Okay, we want to make it look like slope-intercept form, which again it's not coming for a while. But this is the reason that we're doing it. So -2 over -3 would just be a 2/3 x. 18 over -3 would be -6. Okay, so that simplified final answer is the preferred version. Okay, so that is everything that you need to know for literal equations. Please make sure that you have down all of your notes and examples and write down any questions that you have so that they may be answered in class. All right, thanks for watching.